Today we're going to take a look at common and natural logarithms. So there are two special logarithms that are used fairly often in both math and science. And the first one is called a common logarithm. So a common logarithm, or a common log, has a base of 10. And it is written as just log x instead of log base 10 of x. Okay? So because base 10 comes up in a lot of different situations, they have a shorthand way of writing this. So instead of writing log base 10 of x, it's common to see just log x. So if you see a log with no base written, you need to infer that it is a base 10 problem. Okay, so we can use that to evaluate expressions. So this first problem, log of 100, again, that's the same as saying log base 10 of 100. And you're going to get used to seeing this so that you don't have to write log base 10 of 100. So I need to take that 100 and rewrite it as a base 10. So this is log, essentially base 10 of 10 squared. And because, that 2 doesn't look great, 2 squared, there we go. So because the base of the logarithm and the base of the exponential inside are the same, the answer is just the exponent. So the value of this is just a 2. Okay. But again, writing that base 10 in the log is optional now. It's no longer required. So when I look at problem number 2, log of 1 over 1,000, I can go through and I can make that into just log. I'm not going to write the base 10 this time. I'm just going to write it as 1 over 10. Let's see, 10 to the third power is equal to 1,000. So this is really log of 10 to the negative third power. Remember, a positive exponent in the denominator becomes a negative exponent in the numerator. And because we really truly know that there's a little itty-bitty 10 there, this is equal to just negative 3. Okay? So again, if you see a log with no base, you can write that it is log base 10. That is the common notation for log base 10. Okay. So the next part is about a special number. There's a special number called e, which is kind of like pi with circles, but e is a very commonly used value when it comes to things like exponential growth and exponential decay. All right, so what is e? What is that number? And it comes from this statement right here. So we have the limit as n approaches infinity. Now, we haven't talked about limits very much, but we have talked about n behavior, and we've looked at as x approaches infinity and as x approaches negative infinity. So this is like saying, as x approaches infinity, what will the value of this expression become? What will it get closer and closer to? So that means if I'm plugging a really big number like n equals 100, then 1,000, then 10,000, then 1,000,000, and so on, we're going to get closer and closer to this value over here, and this value is equal to the number e, okay? It's approximately 2.718, but like pi, it's an irrational number that goes on forever and ever, and it never repeats, okay? So don't worry so much about where the number comes from, just understand that when we see an e written, it's not a variable, it is a number. Approximately 2.718. Okay? You do not need to memorize that number. E is programmed into every calculator that we're going to use, whether it's scientific or graphing. Okay? So this is the base for what's called a natural logarithm because the number e naturally occurs in lots of different situations. Okay? It is written as ln of x, which is said out loud, natural log of x. Okay, it's the same thing as log base e of x, but this is a shorter notation to use, okay? So we want to figure out, well, what's the natural log of 1, what's the natural log of e, and what's e to the natural log of x? What are these values? Because we can go through and do exact value when it comes to having natural logs as well. All right, so I want to remind you that this is the same thing as saying log base e of 1. And we've talked before about log of 1 and what does that equal? And that's because we're saying e to some exponent, that's our unknown value, has to equal 1. Well, what would go in that box to make that a true statement? Only a number to the 0 power is equal to 1. So this is equal to 0. Okay? So the log of 1 is always equal to 0. That's true when we're talking about a natural log or a common log as well. Okay. So next up, let's take a look at the natural log of e. I want to remind you that natural log again means log base e of e. Okay? And we know that when the base of the logarithm matches the inside, the answer is the exponent. And there is an exponent of 1 right here. This is e to the first power. So this is just equal to 1. So the natural log of e is 1. just like log base 4 of 4 is 1 and log base 7 of 7 is 1, okay? This last one can be rewritten as e to the log base e of x. And we know that when we have an exponential with a logarithm exponent, if the bases match, it all cancels off because they're inverse operations, and it just gives us this inside piece right here. So this is really just equal to plain old x. Okay? So that's an introduction to what a common log and a natural log is.